Hey everybody, today we're doing 3 examples of limits at infinity. First we're going to do a typical rational function example, then we'll do one that has a radical in it, and then we'll do one that's just a polynomial. In each case, we're just using this one big idea, that if you have 1 over x to a power, if the power is positive, as x goes to plus or minus infinity, that thing's going to go to 0, whenever it's defined. So first, let's look at the limit as x goes to negative infinity, 5 minus x squared over x minus 3. We locate the highest power of x on the denominator, so x to the first, and then we divide the top and bottom by x to that power. So I'm going to multiply the top and bottom by 1 over x, same thing. I get the limit as x goes to negative infinity, 5 over x minus x, over 1 minus 3 over x. Both of those smaller fractions, 5 over x and 3 over x, are going to 0. So I'm just left with negative x over 1, or negative x. And as x goes to negative infinity, negative x goes to positive infinity. Negative times a negative is a positive. So this limit does not exist, and in particular it says that this function is going to positive infinity as x gets more and more negative. When you have a radical in the numerator or denominator or both, the process is exactly the same. You locate the highest power of x in the denominator, here the 6, and you want to divide the top and bottom by x to that power, but you got to take into account the radical. So that x to the 6th is actually under a square root, so it's more like an x to the 3rd. So I'm going to multiply the top and bottom by 1 over x to the 3rd. On the top, I get 1 over x plus 2 over x squared minus 1 over x to the 3rd. In the denominator, when I multiply by 1 over x to the 3rd, I want to put that inside the radical. So I'm thinking of it as 1 over the square root of x to the 6th. That's how the 1 over x to the 6th got inside that radical there in the second line. Overall, the denominator becomes square root of 1 minus 4 over x cubed plus 2 over x to the 6th. So using that big idea, the numerator goes to 0, the denominator goes to 1. Overall, I get 0 over 1, which is equal to 0. Finally, let's do a polynomial. So the idea is similar, except there's no denominator here. We're just going to find the highest power term and factor it out. So in this case, it's x to the 5th. We pull that out. We get x to the 5th times 1 over x minus 3. As x goes to positive infinity, the 1 over x goes to 0. So the inside of that parenthesis is just going to be negative 3. So x to the 5th is going to infinity, of course. So overall, I'm going to get negative infinity. Now, you need to be really careful here that you're not just sort of plugging in and seeing infinity minus infinity and getting 0. Infinity minus infinity is an indeterminate. It could be very big, it could be very negative, depending on the functions that are each individually going to infinity. You really have to do more work, and in particular, we typically factor things that have that form. There's a good rule of thumb to know, which is that it's really, when you have a limit at infinity, it's really the highest power exponent that matters. So in this case, it's the 5th power, so that limit of x to the 4th minus 3x to the 5th is going to be the same as the limit as x goes to infinity of negative 3x to the 5th. So only the highest power term. And so that's going to be negative infinity.